Hello everyone, I am Bhagyashree Lakshminarayanan and today I will be demonstrating my data science internship project on customer segmentation. So starting with a brief introduction of the topic, customer segmentation can be defined as the strategy of grouping customers of a business on the basis of similar interests, demographics, behavior, socioeconomic status, etc., which helps the business understand its customer base and market effectively. The advantage obtained upon using this strategy is that customer-specific services and products can be marketed to increase profit. Even target marketing can be applied. In this project for customer segmentation, I have used k-means clustering, a centroid-based unsupervised learning algorithm which is used to form disjoint clusters with minimum Euclidean distance between points of the same cluster and maximum distance from points of the other clusters. For this, several iterations are performed and every point is compared to the centroids obtained in the previous iteration to determine the new clusters. The process is repeated till the clusters remain constant. To implement this, we first import all the required libraries, that is NumPy, Pandas, Matplotlib.pyplot, and Seaborn. We then read the CSV file using the read CSV function of the Pandas library. We then explore the given dataset using various options. The head function prints the first few rows with column names, which is like the preview of the dataset DF, and the shape function will return the number of rows and columns in DF. The describe function will summarize different columns of the dataset by finding out aggregate measures like count, mean, standard deviation, maximum and minimum values, etc. Now by using the dtypes function, we get to know the data types of various columns. Is null.sum gives us the total count of the null values in each column, and here we see that there are none. So there is no processing required to be done with respect to that. Since we do not require the customer ID column for clustering, we proceed to remove that from the dataset using the drop function, giving customer ID as the parameter. Our next step will be knowing more about the distribution of customers that we have. Various visualizations are used for this purpose. Through the count plot, we get the count of the male and female customers in the given data. To get the distribution with respect to the age, we break the given age values into various categories and we find out how many customers lie in each category using bar plot. The same is done with the annual income column and the spending score column. After this, we use the distplot function over the columns, which provides a visual distribution that combines the matplotlib hist function with the Seaborn KDE plot and rugplot functions. Since this function is now depreciated, an alternative method would be to use the distplot or histplot functions, which provides similar functionality and flexibility. After this, we use the boxplot function to get the distribution of the data points across quartiles of each column. And observing this, we see that our data set is nearly free of outliers, which should be points which are lying beyond 1.5 times of the first and the third quartiles. After this, we use the violin plot to find out the distribution of age, annual income, and spending score across classes male and female of the categorical variable gender. Now we import the k-means module from the sklearn.clusters module and come to the 2D implementation of the k-means clustering algorithm. For that, we need to choose any two attributes to cluster, and here I have chosen the annual income and spending score. Others can also be chosen, but I got the best results with these two. It's all experimentation. So one of the prerequisites of the k-means clustering method is to find out k, or the number of clusters that we need to give as a parameter to the model. For this, we can either use domain-specific intuition, or if one has worked on similar project, that value can also be used. But the most versatile method for this is the elbow method, which involves running a loop covering all the k values and plotting a graph of within cluster sum of squares against that particular k value. The k at which the graph forms an elbow and appears to be steadily heading towards 0 is the recommended value of k that we should be using. So when we try the elbow method for annual income and spending score, we get k is equal to 5 as we see in this graph. We apply the k-means clustering algorithm and save the obtained cluster value in a separate attribute called labels in the dataset itself. And then we plot the clusters using the scatter plot function of the matplotlib. And we observe that the distinct clusters are formed using the given colors. Similarly, we can also apply the 3D version of k-means by taking age, annual income, and spending score and cluster them in the same way as we have done over here. So yeah, that is all from my side. And I'm thankful to Exposys Data Labs for providing me this opportunity to explore and learn through this wonderful project. Thank you.